Now let us take few more interview VIVA and basic questions in data structure. So what are the issues that hamper the efficiency in sorting a file? Sorting a file means arranging into ascending or descending order. This is the sorting. And we are being asked a question is that what are the issues that hamper the efficiency in sorting a file? So there are certain issues. First is the length of time required by the programmer in coding a particular sorting program, first of all, amount of machine time necessary for running the particular program, and the amount of space necessary for the particular program. So the efficiency is related to the number of elements, also number of elements which are there, and the sorting algorithm that you're taking. Like if you take bubble sort, it will not be that efficient, but if you take merge sort, it will be quite efficient. It gives you n square, it gives you n log n. So these are the efficiency and spaces also. You need to see that particular sorting algorithm that needs least space as possible. Calculate the efficiency of sequential search. Efficiency of sequential search. The number of comparisons depend on when the record with the argument keys appear in the table. So efficiency of sequential search means if there are numbers. So how efficient is your sequential means one by one search algorithm. So number of comparison, of course, which depends on where the records with the argument key appears in the table. We take the first case, if it appears at the first position, if your element is here itself, then we would require only one comparison. First element will come across and we'll say, okay, our value is here only, and we'll be happy. If it appears at the last position, for example, this position, so the comparisons will be all n values. So that will be around n comparisons. And the average case will be 1 plus n by 2. Okay, first go or nth go, so 1 plus n by 2 is the average case. Unsuccessful search, of course, we will start from here, we'll reach at the endpoint, that is nth value, and we find that the number is not there. So this is the sequential search failure. So that will also take us to nth values. So we'll have a comparison of n values. So the order of n values will be, that is the efficiency will be order of n, because n will be compared. Is any implicit arguments are passed to a function when it is called? The question is any implicit arguments are passed to a function when it is called? Yes. There is a set of implicit argument that contain information necessary for the function to execute and return correctly. So one of them is the return address, which is stored within the function's data area, and at the time of returning to the calling program, the address is then retrieved, and then the function branches to that location. Next is parenthesis is never required in postfix and prefix expressions. Why? Why we don't find parenthesis? Means if it is there a plus b minus c, then which to do first? This one or this one? But if you have a, b plus and c minus, then what? We don't require in this postfix notation or expression, we would not require the parenthesis. So the parenthesis is not required because the order of the operators in the postfix and prefix expressions, they by themselves determine the actual order of operations in evaluating the expression. They by themselves determine the actual order of operations in evaluating the expression. Next is list out the areas in which data structures are applied extensively. List out the areas in which the data structures are applied extensively. Data structures are applied everywhere, to a lesser extent, to a larger extent. So compiler design, operating system, DBMS, statistical analysis package, numerical analysis, graphics, artificial intelligence or AI or simulation, everywhere you will find data structure is used immensely. What are the major data structures used in the following areas? Network data model, hierarchical data model. So network data model, hierarchical data model. In this hierarchical data model, the tree will be the good choice or the best choice. Network data model, the graph will be good, but we'll see. RDBMS array, that is array of structures in this network data model you can use. Also, this is also an option, and in this we can use the graph. Okay, of course, graph is the best choice, and for hierarchical data model, as I just suggested, we'll use trees. Now, if you are using C language to implement the heterogeneous linked list, we are using C language to implement the heterogeneous linked list. What pointer type will you use? See, in array, the elements which are there in array, they ought to be of the same data type. You cannot have different data types. But in linked lists, if you want to implement with heterogeneous data type, the pointer type, if you take it as an integer, there will be a problem, because how we are going to put float, or how we are going to work with in this character. For that, the void pointer is the best. So the heterogeneous linked list contains different types in its nodes, and we need a link pointer to connect them. So it is not possible to use the ordinary pointers for this. So we go for the void pointer. This is what I was talking about. So the void pointer is capable of storing pointer to any type, as it is a generic pointer type. Any type it can take. Minimum number of queues needed to implement the priority queue. What are the number of queues? So there will be 2 queues which are required. First, these are 2 queues. One queue is used for actual storing of data, and the another for storing your priorities. Now next is, what is the data structure used to perform recursion? And we have seen recursion a lot now. So stack will be used because of its last in first out property. It remembers its callers or caller, so knows whom to return when the function has to return. In recursion, recursion means a function calling itself till endpoint or the breakpoint is achieved. So recursion makes use of system stack for storing. It uses the system stack. This is very important. You know this, that it uses the system stack for storing the return addresses of the function calls. So every recursive function has its equivalent iterative, that is non-recursive function also. So even when such iterative procedures are written, we can use the explicit stack. If you don't want to use the system stack, you can use the explicit stack to perform the recursion. Next is, what are the notations used in evaluation of arithmetic expression using prefix and postfix norms? Because we know that the name of the person who has devised it, so we call it Polish and reverse Polish notations. Reverse Polish and Polish notations. Now convert the expression this to equivalent prefix and postfix notation. I hope I'll leave it as an exercise for you, but I'll give you the answer. This is the prefix notation and this is the postfix notation. You need to remember that whenever you are doing this, the first preference or the precedence first is this one. Then the multiplication division has equal, but we go to left to right. Then negative and positive, they are also having the equal precedence, but we go again left to right. And in the case of bracket, we perform this parenthesis. This is having the highest priority among all this. So these are the options for you. I hope you will perform this, and these are the answer for your reference. Sorting is not possible by using which of the following methods? Insertion, selection, exchange, or deletion. So is it exchange? The answer is deletion actually. Using insertion, we can perform insertion sort. Using selection, we can perform selection sort. Using exchange, you can perform the bubble sort or various similar sorting methods. But there is no sorting method that can be done just by deleting the elements. List out few of the applications of tree data structure, where tree data structures can be used. See, manipulation of arithmetic expression, symbol table construction, syntax analysis. Tree data structure can be employed here. Now, list out a few of the applications that make use of multi-linked structures. Application which use the multi-linked structures. The answer is sparse matrix, index generation. They use multi-linked structures. In tree construction, which is the suitable efficient data structure? Tree. So you can use a linked list in tree. So the best one would be array. You have linked list, you have stack queue. The best answer would be linked list. You can use linked list, and this will be efficient also for implementing your tree construction. So what is the type of the algorithm used in solving the 8 queens problem? Are you aware of the backtracking problem? Or backtracking. So backtracking is the type of the algorithm used in solving the 8 queens problem. In an AVL tree is kind of binary tree only, but it follows certain rules. That is, if the difference of height, it goes, it should be -1, 0 and 1 only. If it is not these, the balancing has to be done. So at which condition the balancing is to be done? The answer is if the pivotal value of the height factor, that is the height factor, if it is greater than 1 or less than -1, then we do the balancing. There are 8, 15, 13, 14 nodes were there in 4 different trees. These are the 4 nodes. Which of them could have formed a binary tree? See, the answer is 15. Why? In general, you had 2 n-1 nodes in a binary tree. So by the method of elimination, full binary tree contain odd numbers of nodes. So there cannot be full binary trees with 8 and 14. Okay, it should contain odd number of nodes. So rejected. 30 nodes you can perform the complete binary tree, but it will not be a full binary tree. So answer will be 15. Full and complete binary trees, they are different. Okay, all full binary trees are complete binary trees, but this is not true for the otherwise manner. In RDBMS, what is the efficient data structure used in internal storage representation? Internal storage representation, RDBMS, efficient data structure. We use the B plus tree. Why B plus tree, B tree, B plus tree? We use B tree because in B plus tree, all the data is stored only in the leaf node. That makes searching easier. B plus tree, all the data which is stored, they are only in leaf tree. And moreover, you can also perform one more thing. The leaf node, they can be connected together, or they can be indicating one another. So you can also traverse. So this corresponds to the record that shall be stored in the leaf nodes. One of the following tree structure which is efficient considering the space and time complexity is what? These are options for you. And of course the answer would be your complete binary tree, this one. Full binary tree loses its nature when operation of insertion and deletions are done. So for incomplete binary tree, this one. Extra property of complete binary tree is to maintain even after the operation like addition, deletions are done. Right? So our answer would be complete binary tree. What is a spanning tree? What do we mean by a spanning tree? A spanning tree is a tree associated with a network. So all the nodes of the graph appear on the tree just once. So a minimum spanning tree is a spanning tree organized so that the total edge weight between the nodes is minimized. Next is, does the minimum spanning tree of a graph give the shortest distance between any two specified nodes? Well, this not be true. The answer is no, because minimum spanning tree or MST, it shows that the total weight of the tree is kept at its minimum. But it doesn't mean that the distance between any two nodes involved in the minimum spanning tree is minimum. Next is whether linked list is linear or non-linear data structure. See, in terms of storage it is non-linear, but in terms of accessing it is linear. So according to the storage, linked list is non-linear, otherwise it is linear. So these were all questions we covered with respect to the interview and VIVA, because these are generally asked. So hope you benefited. Thank you so much. Take care.